I'm with MSR Program Management. I'm Chris Rebholz, and I'm with MSR Program Management. And we try to get some more interaction with the product groups so that you guys, especially in the PPRC and so forth, can know what's coming out of the product groups these days. And Pedro Celis is one of the SQL Server architects. And since SQL Server is going to start to be the basis for all storage throughout the company, I thought it would be a good thing for you to see what's going to be coming out of that group shortly. So Pedro's going to give an overview of all the features of Yukon and also sort of give you some explanations of what the features are useful for so you can start to think about how to use them in research, in the tool testing, and so forth. So, Pedro?
Okay, well, again, my name is Pedro Celis. I'm an architect in SQL Server, and what I have here is a presentation on the next release of SQL Server that is called Yukon, or Yukon. I think it's Yukon. Okay. And, yes, I don't know.
It doesn't seem to be on.
Can you turn it on?
Ta-dun. Hey, there you go. I didn't do anything.
I got it.
Okay. Okay, so this is what I have in this presentation. I want to spend a couple of slides talking a little bit about the previous releases of SQL Server and how this release is different from the previous ones. Then I'm going to give a little overview of the scope of Yukon, kind of the main themes, if you like. And then the bulk of the presentation is some technical details on Yukon, divided in different areas. At the end, I hope we have some time to get some feedback. Otherwise, I can stand at the end and talk with you guys. Okay, so this is a little bit of where we're coming from. I don't know if you know the story about SQL Server in Microsoft. It was an original product that was bought from Sybase. 7.0 was a pretty big rewrite of that. 7.0 was a big release. It was a lot of time in the making. And at that time, we knew mostly what we were going to build. And we added a lot of things. We rewrote the query processor. We added parallelism. We wrote a whole new storage engine. So it was a pretty big release, and it was a pretty successful release in the sense that the product is a lot more solid than it used to be. 6.5 and the previous releases had not a pretty good reputation as far as the database being a solid product. That was the main accomplishment of 7.0. We also raised the bar quite a bit on the ease of use in that. SQL 2000 was what was supposed to be a minor release after that. It was originally going to be called 7.5, eventually became 8, eventually became SQL 2000. And it was supposed to be a quick release. We were mostly cleaning up and adding several new features. Yukon is a pretty big release for us because we are doing quite a bit of innovation in it. We are adding a lot of things that were not in any of the previous products. In 7.0, we're doing a lot of innovation about how to implement things solidly, but not necessarily extending the language and extending the capabilities of it. We're extending utilities and other manageability areas, but not so much the programming side, if you like. And in Yukon, we have a lot of innovation of that. In addition, we have quite a bit of investment in continuing the evolution that we started with 7.0. There were parts of 7.0 that were not rewritten, from 6.5, and they're pretty much all being rewritten in this release. In particular, what we call the normalizer now becomes the algebraizer, and some things in the access methods. Okay. Now, kind of when we started this release, we had a lot of requirements, if you like, on what the direction of the product. Many of them came from this better together strategy. Microsoft is realizing the value of SQL Server not only as a product that we can sell to customers and generate revenue, which has been doing pretty good in that, but also as the technology that we can use as the platform to many other services. So this better together strategy means integrating it better with the other strengths that Microsoft has. The way we can win in the marketplace is not just by making a better database product, but by leveraging other aspects of Microsoft. The CLR in particular has been a big effort in Yukon release. Instead of us taking our programming language called T-SQL, which is a very poor programming language, and adding lots and lots of things to that, the strategy that we took is we took the CLR and put it inside of SQL. and then adding a way to access the database from inside the CLR inside the SQL Server. So our store procedures can be done in that. XML and SOAP is another big emphasis. I'll talk a little bit about an XML data type and some of the work we're doing there. Caching is another thing. It was an effort we started some time ago where we're seeing that normally the way people do their work is they cache data from the application server from the database. And that cache is not necessarily as a set of records. It's already transformed into something else, into an XML document, into some other data structure. And then they're faced with the problem of presenting stale data or having to go and poll again. I go and poll the data to make sure that it's not too old, and I'm doing unnecessarily polling. But if I don't do polling often enough, then I'm presenting stale data. And one of the features that we have in this release is the ability to be able to tie a cache that you have of data that is in a completely different representation to the database, so you can get a notification when that data got changed. Let me go a little bit to the next slides. This is a little bit about some of the bigger pieces added to Yukon. One of the big things is we had pretty much one way of getting to the SQL Server process. That was the netleafs or the TDS protocol. TDS is the format of the messages, and netleafs is the set of APIs that you use to access the SQL Server. One of the things that is being added in this release is the ability to go into server using HTTP. And we have a whole new set of APIs that go through either or one or the other of those two ways of getting into the server. The SQL XML part of the APIs that we have is going to be expanded quite a bit from what was done in SQL 2000. So this is a alphabet soup that we have here, a bunch of little things. I'm going to go and step back a little bit about what is the big investments that we're doing in this server. They're basically in three areas: scalability, availability, and programmability. Okay, those are the three big themes that we have. Okay. Scalability. And scalability, a lot of the emphasis on scale up, not scale out, but scale up. Okay. Originally, what we were planning to do in Yukon, we were thinking of doing a lot of clustering effort and a lot of big scale out investment. We did a big down payment on that investment, but not a lot of things that you can see in the product. On the scale, let me talk a little bit about scale out. We decided to scale back our scale out plans to make room for programmability and other things. But the scale out effort, let me move. They told me they had 6 cameras here and I can move it. They'll follow me, so I'll see if it's true. On the scale out effort, many of the big things that we had were infrastructure problems internally. How we handled state on connections, our catalog data, how it was structured, the fact that we didn't have partitioning, and we added a lot of those things in this release. So we made a payment for a scale-out strategy, but you don't really see any features in that. So we basically re-implemented a lot of our server, thinking how we're going to scale out in this release, but you don't see a lot of scale-out features. But we do have a big scale-up investment. Partition is one big thing that was added in this release. A lot of online operations. Online index build is the biggest one of them, but there's a couple of other scalability issues in that space. And the other one is SMP enhancements. We're changing our internal notion of threads and other things, or what we call the SOS layer, the SQL OS layer. It's kind of a not very good name, SOS, but it just means the SQL operating system. I'll get you in a second. We're changing that and how we do threads and other things to make sure that we can run in a NUMA environment, in an environment where all memory is not the same, all I/O is not the same, and we can segregate I/Os, we can segregate threads, we can segregate connections to allow a better scale up. You got a question?
What does scale up mean?
Oh, sorry, scale up. Scale up means going to a bigger machine, big machine. We have a couple of Unisys machines that are 16 processor, 32 processors. They're normally built from 4 processor quads, they call them, units that have memory bus and whatever, and then they have fancy interconnect between the memory buses and these CPU buses. And as a result of that, it's not an SMP. It's no longer a symmetrical multiprocessor. Things are not symmetric. Depending on which I/O, from which CPU you want to do an I/O, it may cost you different, and memory may cost you different. So one is the hardware architecture itself is not symmetrical. The other thing is, you gain a lot by segregating things, by making sure that this processor is always accessing this set of pages. That way, the cache lines that the processor has, have a better cache-hit ratio, and you're not fighting for that cache line with other processors. So as you scale up in these, big machines, there's a lot of, changes that you can do, affinity that you can do to improve your performance. Okay, availability. Availability was another big investment. Now, scalability and availability are two big investments that are, if you like, more interesting to our current customers. They're not so much part of our better together story with the rest of Microsoft. They are more part of, this being a solid database product that can be used in the enterprise, in more and more bigger applications. In the availability, we have online partial database restore. It used to be that if you lost your database, you can go and restore it. If part of it is broken, you have to restore the whole thing. Because we didn't allow you to restore only that part that was broken. So now you can restore only the part that is broken. And a number of other things. I'll go a little bit more into features there. The other thing is real-time log shipment. This is a little bit for disaster recovery and other scenarios where I have a machine, I have my database, and I want to have a backup of that someplace else. A whole copy of it, not sharing the disk, a whole copy of it. So if the building comes down, I still have my service over there, and I can still, process transactions even though I lost the computer. Yeah.
Can you explain what you mean by partitions and online index build?
I'll go into those things later. Okay, programmability. This is the big area, or one of the areas where there's a lot of innovation. CLR is one of them, the CLR integration. The new Visual Studio languages can now be used to write stored procedures inside of SQL. So we took the path that instead of extending T-SQL, the programming language we have, we're taking these programming languages and allowing them to be inside the database, and you can write your stored procedures and user-defined functions in these languages. Right? XML integration is another thing. There's data that comes that is XML data that is not necessarily, you don't have necessarily good schemas for them. You don't know how to map it to a set of relational tables. So we have something called an XML data type that allows you to do that. And also a lot of investment in being able to take XML documents and shred them into relational part and an XML part, back and forth. A number of other SQL enhancements, I'll go a little bit into some of these things. Okay, so this is the disclaimer slide. Okay. We're in the middle of Yukon. We finished M3. We have 2 milestones left to do. So everything is kind of 80% done, which that really means, you know what 80% means, right? If any of you got a PhD, you know that the last year is the one that takes the longest, right? So there's a lot of things that may be cut. So I'm going to explain things here, and there may be some things that may change, right? But also, I'm interested in getting feedback. If you guys are really passionate about some things, that's always good feedback. Right? Yep.
The CLR stuff, that's going to help us within Microsoft, other groups, using SQL Server. Uh-huh. Is that going to help people like Siebel or PeopleSoft?
So the question was, the CLR stuff helps us internally in Microsoft, and it's going to really help. Is it really going to help our customers? Well, there are 2 parts of it. One is we need to improve our ability, the ability we give our customers to do more complex, language, business logic inside the database. We can take the approach that we can go to extend just T-SQL. Right? Some of our competitors, what they have done is say, well, instead of doing that, PL/SQL, whatever language they use, they're going to take Java, and put that in the database. We took a more language-neutral approach, and we took the CLR. Now, the thing that is really advantageous is that we have, in this company, a big investment in programming language tools and, frameworks and a lot of other things that makes it very easy for people to develop applications. That's why there are so many Visual Basic programmers, right? Because we give tools and an environment that allows people to write very simple things. So it will help customers that want to use the CLR to build their middle tier logic, and now they want to push some of that logic into the database for performance reasons and whatever. SQL in particular, I'm not sure, because they might want to stay more database neutral, and not do that. Right? If they're willing to use C++ or C# or anything like that, they can have the business logic run either inside the server or in the middle tier, but it will run in the server in the case of SQL Server. Okay. So we had kind of 3 big themes, and now I'm going to go down into more specific features.
You've done a lot of optimizations when you put the CLR in, because the CLR's got its own thread pooling, and it seems quite at odds with SQL Server.
Yes. So I guess the question is, the CLR is a little bit of its own operating system, if you like, and we're a little of our own operating system. So how do the two, coexist? Well, very carefully, very painfully sometimes. And this is one of the areas where we've been pushing back a lot of requirements to the CLR team about being hostable. Right? We want them to not, for example, start doing garbage collection and take that thread and spend a lot of time looking at memory and not yielding, because we have a yielding model in our both little operating system, right? So we spend some time with them on having a set of APIs such that they can be hostable by an OS, which is us in this case, right? Memory management is the other one, right? We never want to take a page fault. We always manage. We can grow and shrink our memory, our buffer pool, and things like that to make sure we're not patient. And so there's another interplay with them as they want to grow their buffer pools or their memory pools. We may want to shrink our buffer pools. Okay, so I'm going to go down this list of things: access methods, availability features, utilities, some cool query engine enhancements, and assorted things that I couldn't classify. Access methods. Well, access methods is one of the few components that the storage engine did not re-architect in 7.0. We rewrote big parts of our engine, but we did not re-architect this particular part. And in Yukon, it's completely rewritten. Now, why did we decide to do that? Well, one, is maintainability. It's a lot easier. We felt, we could have better maintainability if we rewrote it. But the main thing is we had a large set of things we wanted to do. Large row supports, merge indices, prefix suffix compression, prefix unique indices. I'm going to explain this in a moment. And we felt we got a better bang for the buck if we wrote it and did all these things, and instead of trying to fit these things into the existing code. So it was, cost-benefit analysis, not only maintainability analysis, that convinced us we need to do that. So let me talk about a couple of these features. Large record support. In SQL, you have a row that, there's 2 things here. One is we have a data type called large varchar. And it's known as varchar max. So you put varchar, you don't put a number, you just put the keyword max in parentheses. That means that it's, unlimited size, that column. And this will normally you will use in the place where today you use a blob. Except that blobs in SQL Server, the way they're implemented, a lot of that is inherited from the Sybase days, are not first-class data types. There are a lot of restrictions if you use a blob. Right? If you want to, sort the result set that has a blob there, well, sorry, you cannot do that. If you want to, do heterogeneous query, well, yeah, you can do it, but there's all these restrictions. Right? There are lots and lots of restrictions with blobs, varchar max is kind of a cleanup of that. It's a first-class data type. Anything you can do with the varchar, you can do with the varchar max. You can run any methods on them. Anything you can do on that data type. And it's implemented. We feel that a lot of customers may have something here that very often is small, but every once in a while is very large. That's a very common scenario. So we have this optimization that we will store the value inside the row if it fits, and only if it doesn't fit, we will store it, out of row, unlike the blobs. Right? And we kind of took that ability and we propagated to other varchar columns that have a maximum size. So now if you have a row that, before wouldn't fit, now we will be able to make it fit in a page. We will take certain columns and store them, in a separate page. We're leveraging a lot of the work we're doing for Varchar Max and giving some of those same benefits as far as storage to regular varchars. Yes?
So is there any reason why customers would continue using blobs?
I don't. The question was, is there any reason why customers should continue using blobs? Or another way of asking the question is there anything you can do with a blob that you couldn't do with a varchar? Right? Some advantage blob still has it. I cannot think of any. Okay, merchant. This is a pretty big feature also. Who knows what a B tree is? Okay, who doesn't know what a B tree is? Okay, who's sitting next to somebody who doesn't know what a B tree is? A B tree is a data structure to store records on disk. It's not that complicated. It's a search tree. The way it normally works is at the leaf levels you have a set of records. They're sorted by some key, and then the inner levels of the tree are just branching. This, if you're looking at something great, and this value go this way, otherwise go that way. Right? And you tend to have a big branching factor in the inner pages of the tree. Right? And B trees is a way of updating this search tree such that it's always balanced, right? Same height. You don't have some leaves deeper than others. They're all at the same height. Okay, so what this merge indices does is we allow to put different type of records in the same B tree. Today, in a given B tree, a given index, all records are of the same type. They come from the same table or they come from the same index. Now you can put records of different types that have a common key, if you like, a way of producing a total order between them, in the same B tree. So you have records of different types. So this yields a single I/O behavior for complex objects. There are a lot of complex objects that you have that the way you store them as records of different tables. A typical example is an order. Right? I have an order, and the order has a bunch of line items. So I will store some information specific for the order in one table and information specific for each line item in another table. Now, when I go and access the order, I tend to do one I/O to get the order part of it, and another I/O to get all the line item records. It'll probably be the same page, a single I/O. Right? But now you can intermingle those records in the same B tree, and with the single I/O get them all. Right? So this is a pretty great performance feature for large and small systems. I think I have an example here, with the order and line items. So before we'll have the order records in one B tree and the line item records in another B tree. With this new feature, they get laid out all intermingled, by using a common key like the order number. Okay, prefix-suffix truncation is another very important thing. Records like the order, line items, for example, are going to have that order key as the first set of bytes in the row, right? So you can get better storage utilization if you compress that thing out. The first record in the page has the order number, and all the other records, if it's the same order number, don't store it there. Truncate the prefix of it. Same thing with the suffix. And the suffix is more for the internal pages of the B tree. In my internal page of the B tree, I'm coming with a key value. I'm looking at a point here. I'm going to do a comparison, and I'm going to go either left or right. If I already did the prefix compression, I can also truncate any suffix that doesn't help me to make the decision between this key value and the next one. If this is B blah 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 and the other one is C blah blah blah, well, I don't care what the blah blah blahs are. I only care the fact that this one starts with C and this one starts with B. That's enough to tell me which way I'm going to be going. So we do both prefix and suffix compression. Kind of a big impediment for doing this before was that we did not have what's called normalized keys. We have a key that is a collection of data types. And when you want to compare two of these vectors, you have to go and say, okay, well, these two are floats, so I have to compare them, using some criteria. these two are integers, I need to compare to some criteria. These two are characters, the strings with some collation, I need to compare them to some other criteria. Normalization is a function that you apply on this vector. So you get a byte stream, and you say, well, I don't care anymore about data types, I don't care anymore about columns. You just look at byte by byte. And whenever this byte is bigger than that one, then this vector is bigger than that vector. So in this new access methods, we're normalizing keys, and that allows us to do prefix and suffix truncation. And we don't know about column boundaries. We're just dropping bytes as far as we know. Okay. This is another nice feature we have. It's called prefix unique indices. So in SQL Server, you can create a table, and then you can create indices on those tables. And indices are useful if you're going to be searching based on those criteria. And there's something else called unique indices. So I may have a table T1 that has column C1 and C2, and the combination C1, C2, I want to enforce uniqueness on it. I want to make sure that there's a single value for that combination of C1 and C2 value. So the way we do that is we create an index, we put the values of those columns for every row in the index, and whenever you insert a new row, we insert a row in the index. If there's a duplicate, we say, sorry, you cannot insert this. This is the ability to say, well, as long as you're creating that index, with that column C1 and C2, could you also put column C3 and C4 there? Because I have a lot of queries that could be satisfied by that index if you had those 4 columns. But I also want you to enforce uniqueness. So I want you to do 2 things. I want you to enforce uniqueness on the C1 and C2 part, but I want you to carry the extra columns so that the index can satisfy many of my queries. Right? A lot of my queries might be, give me C1 to C4, where C1 equals to something and C2 greater than something. So I can do it with the index. Without this feature, we have the index to enforce the uniqueness, but we may go and get that row there, but now to get the columns C3 and C4, we have to go and do another search down another B tree to get those column values from the main cluster index. Question?
Can you elaborate on the prefix truncation? The previous slide.
What about?
Can you elaborate how you actually do it?
The prefix compression? Sure.
Yeah.
Let me go back a little bit to that prefix compression. So the question is, can I elaborate a little bit on the prefix compression? Okay. So prefix compression, you can do it both in the interior nodes of the B tree and at the leaf level. So let me just talk at the leaf level. So I have a record, and the record has, those columns, that I had before, C1 to C4. And they are clustered, they are laid out such that they're sorted by those vectors, C1 to C4. Well, if you look at one record and you look at the next record, they're probably going to have the same value C1. They're also probably going to have the same value C2, and maybe even the same value C3, The C4 might be different, right? So one thing that you can do is you can say, well, in the first record on the page, I'm going to store C1 to C4. In the next record, I say, well, start at this byte. All the other bytes are the same as the first record of the page, right? And then so on and so on. So that allows you to store more records in a given page and gives you better, I/O performance, right?
Do you dynamically compute that, or do you require the schema or something to tell you when to use prefix truncation?
No, we dynamically compute that. I don't know if we have a knob for you to turn it off or something like that, but basically you don't have to do anything. Okay, so it was unique indices. Another thing is you can result in fewer indices. We have a lot of customers that create a unique index on C1 and C2, and then a non-unique index on all of them. So the first one is used to enforce uniqueness when you insert, and the second one is to satisfy queries that require those, 4 indices. And this is one of the things we do. Okay, versioning. This is a very big feature. And this allows you to have better concurrency. Basically, allows you to have the ability that readers will never block a writer. Okay. And it's a mode of transaction isolation. So if you don't understand anything of that, let me back up a little bit here. So a very common thing in database systems is that you want to execute a set of transactions just like if they were executed serially. Even though you're executing them concurrently, you want the final behavior to be the same as if they had been executed in some serial order. So, he's doing a transaction where he's modifying something, he's doing a transaction where he's reading that thing he's modifying and something else, and you want at the end, even though they were running at the same time, you want the behavior that they see to be consistent with this one executed first and then that one, or the other way around. I don't really care as long as it's one or the other, and you don't see something that shows the effects of another transaction that was in flight. So that's kind of what's called serializable behavior. Now, normally database systems do something simple that is called locking. Somebody's going to go and modify a value, I lock it. Nobody can read it until I finish with it. Right? So if I modify something, I'm going to lock it, and that reader cannot look at that value until I commit this transaction, and then I release, and then the reader can go on. But the readers also have to lock things, because they may go and read a value, then a transaction goes and changes something, and then read the other value, and now they get something that is not consistent, because they saw half of one transaction, but not the other. Right? Suppose these two values were always supposed to be the same. Every transaction changes this, also changes that. If you go and read this one, then in the meantime somebody goes and changes this one, and now you go and read it, they're no longer the same. Okay? So you also get read locks. And then that normally gives you low concurrency. So people say, okay, well, I'm willing to live with inconsistent behaviors. I want to see transaction committed values, but not necessarily the collection of them were all valid at some point in time or something like that. This gives you the ability to give a better behavior. And this is a feature that Oracle has. We did it slightly different because they have a set of anomalies that we don't like. And this basically means, okay, suppose this transaction is modifying a value, and there's another transaction that is reading this value in something else. Now, that transaction started some time ago, but had not gotten around to reading this particular value. With versioning, whenever we modify this value, we keep the old version of the row route. When he eventually decides to come and read this value, he will read the old version of the row and continue on. So this reader is not blocking the writer. If he gets here before the writer, he's not blocking it, and also he's not waiting on the writer. You got a question?
Two questions, actually. One, how, from a marketing point of view, do we not vindicate Oracle's model like this? And how do you address all the issues Oracle has, like rollback segments not being big enough and that sort of?
Okay. So the question, or two questions. One is, aren't by us finally doing this, finally admitting that Oracle had a better model, how are we handling that behavior? And the second one is, Oracle's implementation has a set of complications. And how are we dealing with, what solutions do we have to those problems? So, for the first one, we are doing versioning right while they did it wrong. Okay. They have a set of anomalies, serious anomalies, where you can have kind of the last update behavior. That was one of the key things we didn't want to do. Or one of the main obstacles that we had in implementing this, just like they did it, which is a cheaper way of implementing it, if you like, is that it does introduce a set of anomalies. So we don't have any of those anomalies. And as far as the second one, we don't have rollback segments like they do. They have an undo log separate from their redo log. We have a common undo and redo log. So we're not relying on the rollback segment like they do for version. We are relying on keeping all versions of the rows in our B trees. Now we're going to use free space on the pages of the B tree to store the old versions of the row. And whenever we need to, we may go and grab another page from a temporary from the place where we put temporary files, to put those records there. So our records are going to be, intermingled, if you like, with the record that you were trying to access, or closer to the record you're trying to access, which gives better behavior. So we're not, we don't have many of the problems they have because we don't start it from this architecture that they have a separate redo and undo logs, and so we don't have rollback segments. This is an important feature because we do have a lot of customers that are moving from Oracle. And when they come and implement on SQL Server, they find that they have concurrency problems. And they have to, rethink their application. In some sense they did it wrong, we tell them, and now they have to rethink it. So this allows them a much, lower bar, for those migrations. We had a similar scenario with when we went from 6.5 to 7.0. Kind of related to this doing the application wrong. There were a lot of applications that had a lot of deadlocks. And we had a very aggressive deadlock detector. Every time you go and got a lock and somebody else had it, we want to go and change, search and say, am I in a deadlock? That seemed wrong. Deadlocks are not common. You should wait a little bit, and if you don't get the lock after a while, then go and say, well, am I in a deadlock? And then I have to kill the transaction. Well, when we changed that, we found out that many applications don't work because they actually coded them in a way that there's a lot of deadlocks, and they rely on a very aggressive deadlock detector, to bail them out. So now we have a dynamic scheme where, we are aggressive or not depending on what we see the system doing. So that reminds me of this, kind of you did the application wrong, but you don't care. It used to work, now it doesn't work, right? Okay. Still doing good in time, so that's versioning. Partitioning support. This is another pretty big feature. And the term partitioning here has nothing to do with clusters or multiple machines. So I guess that's where the term intra-node partitioning is. So the scenario here is I have a table. The table is pretty big. And I'm going to partition the rows that I have in this table into 3 groups, right? And I'm going to put one group, in this B3, another group in this B3, and the third group over there. Right? Whenever I go and want to search for a row, based on the value of the partitioning keys, I decide, I'm going to search in that B3 or in this one or in that one. Right? There are different reasons for doing this. One of them have to do with scalability. The fact that I can segregate things like that gives me a little bit better behavior if I can also segregate the guys that are accessing this data from the guys that are accessing this data, right? And do some thread affinity and process affinity in large scale systems. But the main, one of the main interests in this has to do actually with manageability. There's a lot of time data that people want to partition based on time. So I have a month here, the next month here, the next month there. That happens to be the hot month. Everybody's accessing that month and not so much this. So I get better density in my hot data. I keep it better in my cache because I have segregated that way. I'm also, I can drop, all these guys here, very simply and not go and try to peel, records from every place. Right? So there's manageability aspects of why partitioning is of interest, and there's also performance, reasons why this is of interest. And I guess a third interest in us is this is a down payment for scale-out architecture. In the scale architecture, partitioning is also very important. So a lot of the work that we're doing here will allow us to, be able to do scale-out later. We're going to support a lot of utilities at the partition level, so I can go and drop a given partition or restore it. I can back up a given partition and restore it. And that's really what, people that use partition do. Our design point is, partitions are pretty big. So the table is a collection of those partitions, and a database supports tens or hundreds of partitions. Right? Do they have something else here? Okay, any questions on partitioning? No? It was all clear? Okay, backup and restore. I don't, you guys probably don't do backups of your data, right? You probably don't even backup your mail or your presentations or anything. But, for customers, backups are kind of a big deal for them. And a lot of them do backups to these little tapes. And what they discover sometimes is that, they go and do the backup, they get all these tapes, they store them somewhere. The day they need them, they come back and they have a media failure. These tapes are pretty flaky. So we're doing a number of things to, deal with this scenario. We're dealing here with, pretty flaky backup media. So one of it is mirror backups. So when you take a backup, instead of writing one tape, we write 2 copies of the tape at the same time. So now you get 2 of them. If one of them turns out doesn't work well, maybe the other one will work. We also added checksums on backups to make sure we can detect bad data. Because right now, if the media is flaky and we want to read the data, hey, it looks like data, so we put it down, and it's bad, right? So we're now, increasing the integrity of the backup and restore process by adding that. The other thing we're doing is, you may have a page that goes wrong or a file that goes wrong. Your database is storing a collection of files, and one of those files, gets corrupted, by the operating system or something like that, or a page gets somehow corrupted, and you want to restore it. Today, you have to restore a lot of things. You have to bring your database down, but nobody can use the database. So now we have this online file and page recovery. If you try to access that file or that page, you'll get an error saying that data is not available. But in the meantime, you can party on. And while you're partying on, we're loading tapes and looking for the right records to go and recover that particular page. The other is we continue restoring error. We're pretty finicky also. We're doing restores, and hey, we encounter bad data here. There's some pages that I cannot lay out because they're wrong on the tape. We raise our hands and say, sorry, I cannot restore your database. So now we'll continue. Those pages are marked broken, but we continue finishing restore, and then maybe you'll be able to recover that. Maybe you can drop a table, for example, or an index, and you can recreate it very easily. Today we say, sorry, I couldn't restore the whole thing. I don't know if you need that data or not. We don't give you the ability to go to repair the database. So all of this, has to do with that manageability scenarios. Right? Online log shipment. So this is I talked a bit about it at the introduction. So today we have this. You take a database, you take backups of that database. You can send the backups to another machine, across the country, and you can apply the backup over there, and you bring it, you catch it up in time, and then you get the next backup, ship it across, you apply it, and you can use it there. So the secondary lags, from the primary, based on when you took that backup, and maybe 1 hour behind, or maybe 1 day behind, and customers use this quite a bit. They have their disaster recovery site where they're shipping their data to, and they're continually applying logs like that. But, if something happens to the primary site, they lost 1 or 2 hours of transactions. Right? If they're talking about money, that's not good. If you're talking about mail messages, well, that's, a little bit bad. Other things they don't care, right? But a lot of customers do care that they don't lose any of this information. So in Yukon, we have this continuous log shipment. So what happens is we have a connection to the other server where, as we generate log, as we're writing it to the log file, we're sending it to the other side and applying it over there. So the other side is applying, all the changes that are happening over here. The backup site is a copy of the primary bit by bit. Every bit of every file is identical. Then we're taking that log and applying it, to the other side. And then we can do this in what's called one safe or two safe mode. This terminology has been around for a long time. In two safe mode, I go and do a transaction on the primary side. I'm done with the transaction. I want to do a commit. Normally, before I can say, yes, the transaction got committed, I have to wait for that commit record to get to the log. Once the commit record gets to the log, even when the machine crashes, I will read the log and apply all those changes, and your transfer or whatever it was, will happen. It will not get lost. But so what happens if this machine goes down before that log record gets to the other one? You got it already to disk. You already said committed. There's that little window where it hasn't reached the other side, and the transfer is not committed. So in the two safe mode, we do not reply commit until it's committed on both sides. And you can switch, which side you want or not. And then the interesting thing is, when this one fails, the other one becomes the primary. Our web data, our client connectivity tools know about the primary. You can configure to know about the primary and the secondary. So they just see, okay, the primary failed, I want to reconnect to the secondary. And then open a new connection. They just see as the machine crashed and recovered. And they're working with the secondary. And that now becomes the primary. Eventually, the previous primary wakes up. Now he's the secondary. And the log starts going in the opposite direction.
This is assuming a very robust connection between the two machines, correct? Like if I had one machine in New York and one in San Francisco, I couldn't do this just because of the latency alone, right?
Well, it's not so much the latency. It's because these log systems are all designed to have big latencies. Like, I mean, you're not so concerned about response time as you are about throughput. So you're generating logs. You have a lot of transactions going, a lot of log being generated. You're shipping it over there. So now you may have to wait a little bit longer to acknowledge that, but you're still processing the same number of commits per second, right? As long as you can push that log out, at the same rate.
So you can use an unreliable network for this connection between the two machines.
Well, the only thing about the unreliability of it is as long as you can handle the throughput, as long as the network can handle the throughput of the log that you're generating, right, that you're not backing up that. Okay. And also, if you have unreliable in the sense that you have periods of where things are not getting through. You have a 5-minute period or 1 hour period where the log is not getting across. But now you have the exposure that if you lose the primary side, secondary doesn't really know what happened in the last 5 minutes or 1 hour. Okay. A couple of other miscellaneous availability things. Online index build is a new feature we have. So you have a table. You decide you need an index for that table. But you don't want to stop people from writing into that index. Today, actually, we allow you to keep reading, but not write into that table. So now with this online index build, you can keep updating the table while we're building an index. So we'll go and read the table, start building the index. We'll look at the log that was produced for changes on that table, and we'll catch it up. And then, at the end, we will synchronize things. Okay, well, I have catch up. Now the index and the table are at the same point in time, and now the index is online and can start being used. Right. From now on, anybody who updates the table also has to update the index. Right? So that's a new feature we have. We have fast recovery. So what happens when your server goes down? Well, when your server goes down, comes back up and says, what happened? Well, you went down. Okay, well, what do I have to do now? Well, I have to go and read my log. The first thing that I have to do is read my log to redo, bring me back up to the point in time that I was when I failed, and apply those changes, right? Okay, now that I have brought myself back to that point in time, there are a bunch of transactions that now I have to abort because, they went and modified a bunch of records, but, now after the crash, I no longer have the logs and the other things that transaction needs to, continue progressing, so now I have to undo. So once I, finish my redo, I make the list, okay, all these transactions were not committed, were in flight, I have to undo them, I need to go and find out what they were doing and, reverse those changes. So that's kind of the anatomy of recovery, right? You do a big redo, then undo. So one of the things that we're doing is now we're doing those parallel, phases in parallel. So we can use, in these 32-way processor machines, you're generating a lot of log. All these processors are generating log records. When you recover, you cannot go to a, single stream and say, okay, well, let me take this log record, let me take the next one. You have to parallelize that process, right? So we're doing the redo phase in parallel, and also the undo phase. And then more interestingly is, once you finish doing your redo phase, and you say, okay, well, this is a list of transactions that I need to abort. I also have all the logs that I need to abort those transactions. So I can allow new transactions to come in. And as long as they don't conflict with these transactions that are still in flight, they're in the process of being aborted, those transactions can start doing work, right? So, we did a number of things to make recovery fast. And this, again, as you scale up and you go into bigger systems, recovery can become a pretty big part of your availability concern, because if it takes, a couple of minutes to do your recovery, there goes a couple of your nines, right?
Was it before and how much time it's now?
I don't have any numbers. It always depends on how much activity you were doing, how much log records you were doing, and also how often were your checkpoint records. Sometimes people run with pretty big checkpoint intervals, which is fine as long as you don't have a crash rate. But then your recovery is longer, right?
This online index include a full text index of any text stream?
Good question. I don't know. I doubt it.
Yeah, that's something that we could use.
Yeah, on the full text indices are kind of weird because they are not. They have never been transactionally consistent with the table. So in a sense, they are already the lag in time, right? I mean, you're going to update the table, commit a change to the table, and then the online the full text index gets updated later, after the transaction. So I don't think we have an online creation of full text index unless it's already online today.
Maybe we should come and talk.
Yeah, I don't know how it works, because today, I mean, in essence, our consistency guarantee has never been there. So you could always say, well, just create it today and it's online since, it was inconsistent before, it just was inconsistent. So I don't know, good question. Dedicated mean thread, sometimes it happens that a system, is misbehaving. The system administrator wants to connect in. Sorry, there are no threads, the application is misbehaving and open all connections and all threads are busy, and you cannot go in to go and kill those guys, right? So now we have a dedicated thread that only the system administrator can use it to log in. Simple things like this, are things that you learn when you go and talk to your customers, right? Dynamic AWE memory management, so we can add, more this is adding memory online. You don't bring your system down and you add memory. This is kind of an NT feature. So they can add memory to systems without bringing down the machine, right? But if you add it to the system and SQL Server doesn't use it, well, what good was it? So now we have that. I'm not sure what the status of that one is. It's very much driven by the operating system, right? Okay. Okay here. So in the relational language, there's a lot of other new stuff. The CLR, I talked a little bit about that. XML. We have queuing also. We have part of the product called SQL Server Broker, SSB. Query notifications, semi-memory compile. I'll talk about all these things. Okay, CLR. We talked a little bit about this in the beginning. The CLR is safe, secure, scalable, speedy, and extensible. We couldn't ask for anything more. There's a couple of important points here. I think I made most of this. One is that it's the same mid and server tier programming model. So we have now a whole new set of frameworks, data sets, and a bunch of other things that you can use to access data. So a data set, for example, is, I'm going to go and read a set of rows from a collection of tables. I'm going to load them into a memory cache object, right? I'm going to hold all the, say all the information about the given customer, right? The customer information, all its orders, all its line items, all the shipments, all the payments, and I'm going to load that into a data structure called a data set. And then with that data set, I can have an XML view of that. I can have a class view on that. So this is all part of what's being released in these frameworks. So you can use that programming model that you had in the Meteor. You can now also use it inside the server. So you can write a store procedure that does exactly the same logic inside the server. It's language agnostic, so we don't really know what language you're running this in. You can use these languages to write user-defined functions, user-defined tables. It's a function that returns a set of rows, and user-defined aggregates also. So all that is being added in this release of the server. Our goal is to have performance parity compared to T-SQL. Somebody was asking me, well, what is faster, to write things in T-SQL or to write in URT? And today the answer is depends how much time you stay inside the URT. If you go in, you add two numbers, and you go out, the overhead of going in and out of the URT, overshadows, the work you did inside. If you go in and you do a lot of work inside the URT and you go out, then the overhead of going in and out is not that relevant. You're doing, good work. So it depends a little bit on that. One of the more interesting things that last bullet there, the integrated development and debugging in Visual Studio.NET. So you want to write a store procedure, or a user-defined function that is in the middle of a SQL statement, and you want to debug that thing. Right? You wrote it, you tested it, but now you want to debug it inside the SQL server. So there's quite a bit of work, and some of it's still coming. That we need in Visual Studio.Next, I think it's called the next thing. to allow you to sit in Visual Studio, write this SQL statement that has this user-defined function that you wrote, and be able to, single step through the user-defined function. But that's part of what we're doing. Right? That's the bar that we have here. How many of you are really interested in the CLR? Okay. XML data type. So we have a new data type, a new column type called XML, or type XML, right? XML data.
Quick question on the last one.
Uh-huh.
How does the SQL query optimizer deal with trying to parse through, say, a C# statement or a JavaScript statement to get the same kind of optimized query as you would from T-SQL, which is a much more data
So
specific?
suppose you have a user-defined function that is written in some, language. You compile that language, and then you install that function in SQL, and you give it a name, or we have ways of generating the name from the function name that you have. So now SQL has a binding to that name. It says, whenever you see this name, it means this particular procedure that you pick out of an assembly, right? Okay. Now the interesting thing is that procedure can itself go and call SQL. So you can go back into the SQL engine. So we have a model where we try to cost these guys, and have some costing guys here that can talk more about it. But and then you can quiz them on that. This guy here, okay, you can ask him all you want about what we're doing with costing. But it's not an easy problem because you don't have a clue of what is the distribution of values for the parameters, let alone what is the distribution of the cost of running the function. Right? The function may have a very different cost depending on which parameter value you give. So you need to get a distribution of the input values before you can even talk about what is the average cost of evaluating this function, right? So they are doing some,
Some costing will come from actual real-world data. So functions will be timed, and the average running time, maximum running time, and other statistics will be gathered on the running times, and they will be used inside the optimizer to predict how long a particular function will take, combined with how often you're going to call it.
But it's a very good question, because normally we can go and look at T-SQL and get an idea on how expensive this is. Because we understand the language. Here we don't. We are going into CLR land. We're going to eventually come back with the value, but we have no way of understanding how much time we spend there. And it's, of course, can be a little Turing machine. You don't know if it stops or not. Okay, XML. So we have this data type called XML data type. So let me back up a little bit. What we find is a lot of customers, they have data that they may have an XML schema for that, an XSD for that, an XML. And they want to map that to a collection of relational tables. But there may be parts of it that are not mappable, or they don't know what it is. It's an open schema. They have extra junk that people can send with an order. Right? And I have an order has a fixed set of fields, and then they can have an open schema and say, okay, well, there's these other extra things that you want to put there. Today in SQL Server 2000, we have the ability to map from an XML document to a collection of tables, and whatever's left we put into a blob column. So now instead of putting it into a blob column, we're going to put it into an XML column. That XML column is going to be stored, it's going to be shredded, into the XML tokens, and store each XML token as a row into a little nested table. And we're going to allow, the ability to query that using XPath and XQuery. The other thing we do is we can validate this against a schema. You can say, whenever you insert something into this XML data type, I want you to validate it against a particular schema. So we will, make sure that it satisfies the schema. So here's an example of a query. The syntax there, this syntax here is how you invoke URT procedures or user-defined functions. Right? So you take a column name, colon, and you can call a URT that way. Right? Now we have a fixed set of functions here, this one called XQuery. So this is a function that you're applying on that particular column. Right? And what this function is doing is running this XPath that is going to generate another XML value. It takes an XML value in, If you apply XPath to it, you get an XML value out, right? And that's what you're selecting. And then you have here another method, and it exists, and you're looking for a document that satisfies this particular XPath predicate. Right? And we will go and break it up, that into searchable. We're going to look for something where we're going to look for something, an attribute called @date that satisfies that predicate. And we can even create indices on the tokenized XML data type so we can efficiently satisfy that part of the predicate. Now the XML plans is, the caveats that I had at the beginning, that things change, the XML plans may still change, right?
One of the things I saw really early on in the Yukon stuff was that you were looking to get parity for XML queries and straight SQL queries performance-wise. How's that coming along?
So the question is, at the beginning in Yukon, people were talking about having parity between the XML queries and the relational queries. We have different programming languages, or different query languages. The X query language is still evolving. We don't have yet a complete standard for that. So when we talk about parity, that means, for the relational programming language, we go and analyze terms, and we can go and build indices that allow us to efficiently execute that. That's our philosophy with the X query one. So those queries that I had before, here, there's this @date predicate, right? Now, to really execute this efficiently and find those documents that satisfy that query, I really need to build an index that I can go and find all the @dates and find the ones that do that, and that will point me back to the document. Right? So that's what we're doing. Right? Now, parity, if you define that, okay, well, I can write the same query in SQL and in XML, and it's exactly the same. Well, there's a lot of hand waving in those explanations. Right? But here, the philosophy is that you take that query language, you analyze it, and you build a set of indices that you can do to efficiently execute it. Right?
Right, so your underlying storage is still completely relational.
Right.
Right.
Okay. Queuing. This is actually the area that has still the greatest amount of flux in the product, our queuing support. We have this thing called SQL Server Broker. We have another effort called Indigo, and then there's Bstock. And all three of those products have big areas of overlap. The last 3 months, there's been a lot of alignment between those three products. So a lot of the things that are happening here in queuing are changing. But the basic idea here is that we're adding into SQL Server a couple of things. One is, the ability to have queues in the server. And the important thing about the queue is that whenever I deposit something in this queue, a piece of code gets activated to dequeue it and process it. So it's not so much the fact that you have a queue and you can insert something into the queue, but that triggers the activation of an agent that will go and read that. And that's what the broker is. It's not so much the fact that you have a queue and you can insert something into the queue, but the whole ability to define endpoints for messages and then activation logic that will go and process that message. Right? And like I said, this is still changing, not so much in the underlying plumbing on how you do it, but on syntax issues and other issues as we align Bstock and Indigo, with this effort.
This also relates to pushing notifications out to web clients and things like that. And we're trying to actually get our head around what the actual business event model should be. Of course, the data state change in the server itself, I think, has to be the starting point, whether it's in a queue or a table or whatever. But as you say, there are a number of different ways to do this now, and it's becoming very confusing.
One of the things that SQL Server is doing is the ability to create a lot of notifications on different things. One is notifications on SQL events, okay, I'm running out of threads or something like that. The other is on data, right? I went and read everything about this particular order. I'm caching it in this XML document, and I want to be notified, whenever that changes, right? So for all of those, we're unifying through the set of interfaces that Indigo and the service broker are producing to deliver that notification. Because the hard part is delivering the notification. We can track, things. We can say, okay, I need to notify him, but how do I tell him? Because what you want is, an HTTP message to arrive to you, telling, hey, remove this from your cache, or maybe some WMI event, or some other things like that. So Indigo and SQL Server Broker are all providing these facilities to do this messaging and send this, either a SOAP message, an HTTP message, or some of these other, array of technologies that we have, to deliver the notification. Because inside of SQL Server, we're always having problems with, I want to do these things, but I don't know how to deliver the notification. Now, I can generate the notification, but what do I do with it next? So what we do is we put it into a queue. And now, on that queue, you have somebody that can process it, a piece of logic that can process it, CLR logic or whatever, and say, okay, I'm going to dequeue this, and I'm going to send an HTTP message. I'm going to, insert a row into something else. I'm going to, do some piece of logic to generate that. Okay. And actually, I think this is what I was talking about in this slide. The query-based notification support. This has to do with the example I was doing with the order, right? I want to be able to have an order and cache that data and be able to get notification. We're doing all that through the server broker queues, right? We insert things into those queues, and then you have a set of logic on the other side that processes the notification. And we're also doing notifications for a bunch of SQL things. Whenever a given table gets modified, I want a notification. I want to be told for certain DDL events happen, certain transaction events happen. So this is, more of manageability of the SQL Server, or sometimes people have OLAP server and other things have kind of replicas of the data, and they want to know when that data or the schema for that data, has been modified. Right? Well, a trigger, as we define it in SQL Server, we don't have triggers on catalog data, on catalog tables. Okay, so we have the tables table or the objects table. You cannot define a trigger on that, and part of that is because internally we go directly through the storage engine to modify it, and not through the query processor, right? So we cannot have triggers on it. The other reason is we don't want you to go. I don't want you to allow you to create a trigger on that, and now nobody can drop a table because you've made a logic error in your trigger, right? So we don't allow triggers on system objects. What we allow now is notification of events on certain system events, and including DDL modifications, right? Normally, a trigger is on a particular statement. You define it on a particular table. You define a statement that says, whenever I update it, I want to see the before row and the after row, and you run whatever logic you want. In this case, you don't run any logic. You just get told, hey, this thing got changed. And then asynchronously, not in the same transaction, the event gets generated, right? Or processed, I should say. This is another assorted thing here. Statement.
So if you were going to do an interim solution of firing these events with triggers and you want it to be compatible with the queue, what should you do?
Okay. So one thing that you can do is you can have your trigger insert something into a queue.
In SQL 2000? In SQL 2000?
Not in SQL 2000.
Okay.
In SQL 2000, there are no queues.
So the question is in SQL 2000, if I write a bunch of triggers to fire these state change events and handle them myself, am I going to have to redo all that work in Yukon, or can I leverage that trigger layer?
You can leverage the trigger layer, except that now the delivery mechanism for the notification, you probably want to go and change it to use a queue.
So in other words, what I'm asking is, in Yukon, is the right way to insert to the queue still going to be using a trigger?
I'm hesitant a little bit because we are also going to do the right way. If you're writing a trigger, you've already made that decision,
Yes.
then that's the right thing to do.
Okay.
Now, it may be that the right decision is not to write a trigger, but to rely on our query notification framework that we have.
Okay.
Which we happen to implement by writing triggers and inserting into queues. Right? but it's kind of a higher level programming for you. You're not taking care of all those things yourself. Statement level recompile. Today we get a bunch of SQL statements. We're going to compile them all. We get errors on 3 to 9. The first two compile, but the next 3, all the other ones don't, because the second one created a table, right? And now when we go and execute, we have a problem. We have to recompile each of them, or it may be that first statement drops the table that all the other ones used, so you successfully compile them, but now that table has been dropped and recreated, so that compilation was useless. Right? So we have now this ability to be able to recompile a statement at a time instead of compiling the whole batch. It also helps us with some of our caching logic. And let me row level security. We're adding this thing called row level security. This is similar to what Oracle has, virtual private databases. I think that's what they call it. So I don't know how much you're going to like this. But what happens here is many customers want row level security. They say, okay, I don't want to allow a particular user to see all the rows. I want them to see only some of the rows. Right? And I don't want to go and create a different view, for every user. It goes, okay, well, for you I want to have this, for you I'm going to have something else. I want to everybody use the same set of table names, but they have different privileges. So this is a new feature that was added, that you can alter a table and you can add a constraint. And the constraint is kind of added as another where clause. So when you go and access that table, you have to satisfy this particular constraint to be able to see it. So it's almost like a view, right? But it also applies to updates. Check before update. So before you update the row, you're going to say, well, is the predicate satisfied? Otherwise, you cannot update the row. And you get a meaningful message saying, you don't have permissions to update this row. Instead of, in a view, you don't see the row, so how could you update it? Here you can see the row, but you cannot update the row. Did that make sense? Should I try again? Make sense? Okay.
Since we've added the row-level security in there, is it also auditable, where we can see when people are trying to violate that security? Not just if they're blocked, but there's some other mechanism where that's being recorded that the violation of that security was attempted.
Yeah, that's a good question. I don't believe that this update, can you put some logic here to insert something into a table to create an audit trail?
Yeah, some level of an audit trail, because a lot of customers would like to know if somebody's trying to continually hack into a table or alter a table in some mechanism or change the data when they don't have the rights to do so.
As far as I know, this doesn't have it, and you send me an email and find out, what is our answer to it. Exception handling. This is a feature that is very, very requested, and really the main problem with SQL is in transaction management. In SQL you say, I want to start a transaction, and I go do a statement, and I get an error, and that aborts my transaction. And if you don't handle that error, the next statement starts a new transaction and auto-commits it. And then starts a new transaction and auto-commits it. Right? And what people really want is to have a nicer, cleaner way of dealing with it. So I call another procedure. When it comes back, I have to go and make sure, did the transaction that I started still around, or is he doing something else? So we have now the ability to define handlers and exception handling and the whole thing in T-SQL. Right? And I want to finish now, so let me do this one. Recursive query example. Let me go a little bit to the previous slide. There's a bunch of other extensions to the query language that we do. And what I'm going to do is this one, recursive query, the second to last bullet, also called transitive closure. So this is when I'm doing a bill of materials, or I'm having any self-referencing relationship, and I want to walk it with a single SQL statement. There's no way to do that today with SQL. And I have an employee, a manager and employees, and I want to find all the reports, direct or indirect, from this particular employee. There's no way to write a single SQL statement to do that. You have to write a piece of logic that goes and gets rows, and then you do your own tree walk. So transitive closure is something we added in this release. And the key there is we define that word called closure, that with keyword, and then what you have after that is a table name, closure, that you can reference inside the query. So we define, this is just a name of a table, we're defining it here, and we're using it in the from clause inside it, so it's self-referencing. So the way this works is you have a basis, and then a union all, and an inductive step. Okay, so your basis is, well, I want all the manager and employees from the employee table. That's the basis of this recursive code. And then union all says, okay, this is my inductive step. And what this is doing is saying, okay, find me all the ones that report to this line, and add them to closure. So closure is being used both as an input and an output. So it's a self-referencing query. So this is a new feature that we have. Then you can go say, okay, well, give me from closure everybody who has manager ID file. So this is all not just direct reports, but also indirect reports. And of course, when we execute this, we don't want to go and compute this whole thing for everybody, and then select only the ones for manager ID file. We want to push this down into this definition, and execute it efficiently.
Is there any notion of lazy evaluation of this?
Well, this is just a definition. This is like defining a view. So whenever you reference it here, we're going to optimize it such that we push this down all the way to the basis here. And then we can go and start from that manager all the employees in direct. So that's what you meant by lazy evaluation. This. Now, the key thing is, can I take this and push it just to the basis? That's the analysis we have to do. If we can push it to the basis and still get the right answer, then we will do it. But we have to prove that you can do it. Okay. Let me finish. I gave you a couple of. This is just a rah-rah slide. Nothing here. So I think we have like 7 minutes, so I'm going to finish now and give you a chance to ask some other questions.
Do you have any goals for improving performance, like on the TPCC or D benchmarks? Sort of on the same hardware, will this Yukon be better than the previous version?
Yeah, I'm not sure what they are in particular for TPCC and for TPCH. We have those goals in every milestone. So, for example, in milestone 3, the one we finished last December, we had to be at least 80% of what we were for TPCC. Make sure our performance doesn't go down. And the next one is 90, I think, and the other one. But I don't know what the final release, what the goal is.
Like 105.
Yeah, it's going to be. For TPCH, we're doing pretty good. We're actually above 100 right now. There's other performance release goals for Yukon have to do not on the same hardware, but on the bigger hardware, the big machines.
Right.
Getting the big numbers. And same thing probably with TPCH. We'll probably go and do a bigger size that we wouldn't do on 7.0 and get numbers. One of the things we did in this release is in every, unlike the previous release where when we finished development, performance was really low and we had over 1,000 bugs to fix. What we're doing is we're dividing the release into milestones, which is 3 months of development, 1 month of stabilization. And the exit criteria for a milestone has performance goals and bug goals. So we don't allow more than about 3 bugs per developer throughout the release, and at the end of the milestone, we make sure that we're at there.
Ask about the CLR. Is the CLR optional to have it? I just want to write in T-SQL.
It's not optional, but it doesn't get loaded
Right.
until you do something with it.
Right.
And the interesting question is, do we ourselves do anything that forces it to be loaded? Right? And apparently there's some things in replication, some merge replication functions that if you start using them, even though you're not using CLR as far as you know,
Right.
that will cause the CLR to be
But
loaded.
you're not making T-SQL a .NET language.
No. Yeah, CLR is, everybody loves it, but everybody's afraid of it, so.
My question's on partitioning. If you're horizontally partitioning a table across multiple disks, does it take 3 spindles can that one table that's being partitioned have different page formats depending on the data being stored in that area? For instance, let's say you had the three sections, and one of those sections you wanted a mixed page format versus uniform formatting because you wanted hash indexing or something off of that one.
So the answer is no. You take a table or an index, and for that table index, you define a way in which you want to sort the rows. You define the row layout, if you like, and the way you want to sort the rows. And then you can partition. The partition will segregate those rows into three groups, but they have the same, row format and clustering or row sorting criteria. Now, you can take a table and you can take an index, and each of them is independent decisions, as far as what you write, and they can be partitioned separately and everything. A lot of partitioning advantages also come from the fact that I partition this table, based by date, and I have another table that is also partitioned by date, and I'm joining them. And instead of doing one big join, I'm doing, three little joins, right?
As a follow-up to that, are there any data types that really shouldn't be partitioned? I mean, if you look at, you mentioned date, for instance, anything between or before 1950, I want in this area. Anywhere between 50 and 1970, I want here, and current and back. Are there other data types that you may not want to break a table out or partition a table?
No, I don't think we have any restrictions based on data type. There's two forms of partitioning that we have. One is range partitioning, so you have intervals,
Right.
and the other one is hash partitioning. And in hash partitioning, we take that value, we hash it, and we decide between that set of partitions, right? As you grow, in the case of range partitioning, you can split an interval or join two intervals. That's how you change the partitioning that you have. With hash partitioning, you say, I want to have an extra partition, right? So you go from 3 to 4 partitions. About a third of the records from each partition, a fourth, I guess, from each partition will go to a new partition.
Are there any OO features in Yukon, like inheriting values from one table in a hierarchy to another, or any concepts like that?
Not really, not OO. We've been talking about extended relational, features, nested tables and other things like that. What we do have in Yukon, that is not so much in the database, but is in the web data team, the set of tools to access the database, is a layer that is being called KeyOps. That is an object view of your data. We have an XML view of your data, and now we also have this thing that is an object view of your data. So in an XML view of your data, I have an order, order detail, customer, all that information, and we define an XML schema for that. And we annotate the schema saying, oh, by the way, the customer name comes from this table, and the order quantity comes from here, and then we can generate the SQL statements to load an XML document from a database. Right? So that's the XML view of it, and then you can run XPath on this and do whatever you like. The object view of it is kind of similar. I define an object class, and I say, okay, well, I have a customer object that has these other objects nested in it, and I have pointers between this, linkage between them and whatever. And we annotate that. We have a mapping file, it's called, that says, okay, how you create an object from this collection of tables is through these definitions, and from that we generate the SQL statement to load the object for you. So it's an object view of your data, but it's not really inside the database storing objects or anything like that.
Question is around the log shipping. I wasn't real clear when you talked about the failure process. If machine 1 fails, or so let's start there. Machine 1 was to fail, and the log was not sent over to the machine 2 via that T3 or T1 line, whatever network connectivity you have there, and that failure occurred prior to that log being, or the records bits being sent over there. What's the recovery process?
Okay.
What's the potential?
So the key thing there is if you're running in one safe or two safe mode. If you're running in two safe mode, you have not anything you said is committed is already across the line. Okay. So
when it's committed, when that transaction is committed, that means it's in both. It has been committed in both places.
In both logs, right? In logs on both places. Right? So if you lose the first machine and the second one wakes up, you are guaranteed that transaction is committed on the second machine.
Sure.
So in that case, there's no loss of any transaction. Right? And we have the client layer automatically reconnecting. Right? If you're running one safe mode, then you lost some transactions, right? And for some customers, it's more valuable for them to lose those transactions and start in services than say, well, I won't give any service because I don't know what, transaction they have, right?
Right.
And then what they really need is a mechanism to, when that machine one comes back up, they want to mine a little bit that log before we throw it away, right? So when that machine comes back up, the other one is now the master. Whatever the other one has is the truth. But you said some transactions that were true and you have a set of lost transactions that you want to, know something about them.
Do you see an uptick with an increase in customers' interest in disaster recovery using this mechanism versus just mirroring because of the events of the last 9 months?
Well, I think there's an increase in that, and a lot of our customers discovered that they have backups of their data, that they could be up in service, and they may have lost, a window there, but they could get up in service. But they found out that they were not really able to. They didn't have the right media in it. They didn't have the right version of SQL Server with the right patches. All those things. So the problem is a little bit more complex than just the database, right? To have a disaster recovery site, you need to make sure that you have, everything else around that machine. You have the right version of SQL Server and the right version of the operating system and whatever. The shared disk technology is limited geographically, and so it also, the disk itself can be the source of your disaster, right? Okay, I think we're done because it's done. Thank you.